Nice.
Yeah, that's sick. Look at the...
Oh, that's way cooler now.
Yeah.
Is it because it's warmer?
Probably.
Some fish is gonna smoke. Look at all of these. Yeah, that's probably
So-
pretty attractive to a fish under the water.
So there's actually a reasonable question here, which everyone keeps asking me. Isn't it a bad idea to do this? Like, are we contaminating the environment or something? by doing
nitrogen.
this?
Nitrogen.
Yeah, but it's cool.
Plants
love nitrogen.
Yeah, I mean, it's not like the atmosphere is already something like what? 70, 80% nitrogen anyway. So what's the only waste product that I'm giving out here?
Air.
Yeah, actually a little temperature change is the biggest deal, right?
See that little one that's like dragging along? It also has like this sort of streamer in the water.
So why are some going one way, others backing up?
That's actually a cool question too. So there,
But no, the air is all
actually made
going
an
this
ice
way
puck on
and it's
that
going
one.
against
Oh
the
yeah,
air.
it has some ice on it.
yeah. So
when he dumped them, they scattered like marbles.
so they all got a little bit of initial momentum from me starting this, and actually this is why I thought this would be a good thing for differential equations class, right?
Do you want to keep this on?
Yeah. So the reason that this is a good thing for differential equations class is when we dump this out, right, there's some fluid flow that's happening based on the wind current, right, and the surface of the water.
Yeah.
But into that fluid flow, I'm introducing an initial condition, right? I'm giving that thing both an initial spot in the pond and an initial starting velocity, right? So I'm specifying a y and a y prime. And there's some second order or higher differential equation that's being solved, right, as those little things move around. You guys see that? So, one more.
What would happen if you release that under the water? Like, would it go? It would,
It would
probably float to
float.
the surface, right?
Yeah, it's less dense than water by quite a bit.
But I didn't
It's
know
also
if-
going to boil immediately, right? Okay, so that's a
really
lot.
fast in the water and then start
Colin told
floating.
me he didn't want this back.
Can you give it momentum in the opposite direction and see if it goes?
Okay, so a couple different tosses.
Yeah.
So, for reference, that's roughly a straight pour, and you can see things scattering basically radially from where they were dropped in, right? And that's because as they kind of like hit the water, they all sort of bounce out, and so they give each other some kind of radial velocity.
Looks just like boiling water.
Yeah.
Yeah, yeah, that's not a bad analogy actually, right? And if I give it a little outward momentum,
Whoa.
see that it's going to scatter away from the line that I put it along, right? And it looks like it's scattering a little bit faster off to the right. Yeah, because that's where the wind's kind of pushing.
There must be really low friction.
You actually like trace with your eyes,
there's
follow
the
like a
vapor.
specific part. It's really cool.
Yeah.
Yeah, because it just keeps going.
Yeah, so the cool thing about these is they each have an initial velocity that's kind of given by me throwing them in the water, right? But then they're also being kind of randomly perturbed by just like little micro turbulence in the water and air molecules
Oh, wow.
hitting them, and
Some are just stationary.
Some of them close by are shooting off little particles forward.
oh, they're having little.
Yeah, that one, the small one, push back like a
Yeah, so the cool thing is that they're all kind of a solution to that differential equation that's happening, and also a little bit of Brownian motion that's just like kind of some random element of like air molecules hitting them and stuff, which is why we spend a lot of time thinking about Brownian motion in physics class. You'll notice that actually not a lot of this stuff is hitting the water.
Yeah.
A lot of it's vaporizing in the air.
Yeah.
Why?
Air's hot too. Because you're increasing
Yeah, the air's super hot too. Comparatively. Boiling.
And like a large part of it's dispersing as you throw it.
When you
Because the
You're getting more
increases
the surface area.
Yeah, you're increasing the surface area that's already boiling. So if you increase the surface area of something boiling, basically it turns into air, right? And in this case, it exactly turns into air, which is really cool. And just because this is fun, let's use up the rest.
Was this nitrogen extracted from the air originally? Is that where we get our nitrogen? Just by compression?
Not using up to that.
So we're just putting it back.
There's still a lot.
There's still a lot.
I would appreciate not freezing my feet.
I'm gonna try not to. Does anybody else want to try?
It might be an interesting experiment.
Go for it, Alex.
Just drops it.
No.
Oh, hold on. Whoa. Wow, that's some really close.
Look at like
extremely
completely
satisfying.
covers the surface.
Fun.
Yeah, the fire canyons are like, why the hell is the pond on fire?
I think you guys
Trained to
want
do
Yeah.
It's really cool, actually. The little guys are neat. So if you get super close to them, you can see that there's actually a little raft of ice. You're dripping that.
They're like shooting stuff out of them. You see the little
He's like they're having like little cannon fights with each other.
I gotta go to this.
Yeah, and actually, if you you guys see the little ice lens?
Nice.
little ice guy.
It's like
The
actually
circulation
like
density is absolutely positive everywhere.
yeah.
How about this? Is that good enough?
Tip.
You want it like this?
Nope. Go back, but just tip the camera a little flatter to the surface.
Like this?
Without falling the pond yourself.
Okay, I think I can do that.
Oh, see the bubbles?
They're filling with this gas until they pop.
Yeah, and it does happen that they'll freeze sometimes.
Whoa.
So you're gonna post these videos, right?
Yeah. Oh, nice. Big bubble. We did a little of that last night with soapy water. It's weird.
Hand sanitizer.
Pretty well.
Huh.
It was interesting, yeah.
What happens if you pour a little, like, just like, well, the water would freeze if you pour a bunch of the water into it? It just,
That's a good question. I don't know. When we tried pouring stuff into it last night, it was just strange.
it starts to freeze
Like
the
lots of
material
things
first,
behaved in strange ways. Like, oh.
Right.
Hang on, let me scoop a piece of ice up. Big ice wrap.
It's got this neat lens shape from the depression of how much the nitrogen weighs. Cool.
I was gonna say you could